Hello everyone. Today I want to go over something that I've been working on and I think that you're going to find interesting. If I show you my screen right here, you'll see I have an authentication challenge flow. Now why do I have this all drawn up? It's because I'm working on a tool. I call it SpartanAuth. It's supposed to be a simple microservice that handles all authentication challenges for you. It'll have a very simple API that goes in and out, so you don't have to build authentication. Now this looks pretty complicated, but we can break it down. It's actually not as complicated as you might think, especially when you've gone through and checked all the steps. But then, yeah, I would love to get into this, so let's get started. First off, I wanted to talk about something that I provide as a service, separately from this channel and separately from any kind of employment that I have. It's called BurgX, and BurgX provides modules that you can plug into your code using simple APIs, and it should take a load of work off of you and your developers so that you can focus on what you want to get done, rather than have to build a bunch of tools that may or may not be unique to you and your business. Now, BurgX provides authentication, feature switches, advanced A/B testing, and authorization. So it's very simple to set up. Let's pretend you're running a donut shop. You can come in and manage users on your donut shop app, and you can manage their access to different things. You can manage their feature switches, and you can manage experiments that you want to run on your app or your website. So just right here, here's your user management, and you can manage their information here, save it, and all of this is accessible through an API. In here we have feature switches, and I can turn on things like a weekly donut, tasty donut to advertisement, and you can do much more granular things. This particular feature switch is a rollout, so I have 50% of my users actually see this particular feature. You can do even more advanced, where you have a setting saying, hey, if you're in Utah or if you're in this particular state, depending on the information that you have about your users, you pass it to your feature switch check, and it will evaluate it for you based on the information that you give it. Also, you can create experiments. So this is, I call it advanced A/B testing. It's based on the multi-armed bandit algorithm, for those of you who know it. But multi-armed bandit is something where you can set different rules and run it and see the kind of success or failure that might occur based on that change that you introduced. I would like to show you an example that I actually run on my BurgX webpage, the one that I just showed you right here. If you look at this button, try it out, I have an experiment where it's my call to action. And my call to action, I have a whole bunch of different words that I put into that call to action. And you'll see that it's tried each one a certain amount, and that top number is the success for that particular word and the number of times it's tried it. And you'll have a percentage on this last number here. We'll show you this percentage of success for the click rate. So it shows it keeps track of how many times it's shown and how many times it's clicked, and it will automatically pick the best performing item out of the list that you give it. And this is all based on a very simple API that you can hook into. And real fast, here's your documentation. You click the documentation and it's in Postman. You can actually download this and add it to your workspace in Postman, and you can see how it works. There's also an SDK available in JavaScript currently, Node.js, with full type support. So you can download that, try it out in your Node.js app, and more SDKs are on their way. That's enough of that. I want to talk about SpartanAuth. Why on earth would I be building another authentication tool if I provide it with BurgX? So here's my authentication tool. I provide it. I provide it as a service for others to use, and they can pay me money to use it if they grow to be large to use it. I want to provide and upgrade this particular service with a more capable, more modular approach to authentication. But I have written authentication 100 times, and so I don't want to have to write it again. So I am building SpartanAuth, making authentication simple, and also making it plug and playable for any kind of application. I build it for me, but I'm also going to provide it to you, whoever is interested in using it. So let's get back to this SpartanAuth flow diagram that I've put together. All right, so if you look here, I've got my swim lane. This is just the challenge flow, right? And you'll see why I call it the challenge flow rather than a login flow. So over here, I have a client. I have SpartanAuth, which is the main service that we're building out. DB, which is database, and then webhooks. I wanted to include webhooks because I wanted I want it to be pretty modular and also not require all of the bells and whistles that you need all in one program. If you want to use something like, if you want to add an audit log or maybe an analytics piece, you can configure the webhooks and it will give you that audit. It'll give you the analytics, but SpartanAuth doesn't have to be worried about that. It can just manage the state, the transactions, the logins, and the profiles. And then it'll let other services know that there's been a login or a state change or whatever other information that you want. You can configure SpartanAuth to do it. So that's what webhooks are for. Then the database, I'm actually creating it to be interchangeable for several different types of databases, and we can get into that in another video, how I make the interface work with different databases. And then SpartanAuth. As you can see, SpartanAuth looks really complicated, and that's the thing about swim lane charts. Swim lane charts just look complicated if you're doing them right. But then when you actually go through step by step, you find that they're not as complicated as they look. All right, so let's get into this. We'll zoom in so it's nice and big. But here is the client will initiate a challenge request. This is for the challenge flow, right? And you see I have a username, password, and a one-time password token or whatever. I figure that a challenge can actually have three pieces of information. You have a username, you have a challenge type, and a challenge token, or whatever you want to call it. It could be a password, it could be a token, it could be and any other kind of proof of who you are. And so I wanted to make this interchangeable that way. So there will be three pieces of information you send in this request, and then it will kick off the transaction. So moving down into SpartanAuth, the first thing that we have to do is look up the user that's making the request. So we make a call to the database. It pulls the user's information and any security settings that they might have set up. And I figured that there will be personal security settings and there will be global security settings, because in your app, you may want to require everyone to have MFA, or you may want to make it optional for everyone to have an MFA, but you need to have global and personal security settings. So that information gets pulled from the database, comes back into SpartanAuth, and we have a decision to make. And I made this a very small little branch out, and it says, if the user's not found, then we'll wait 250 milliseconds and then return a 401. The reason we wait 250 milliseconds is what we want to do is make sure that when you process passwords, it actually takes some work on the server side to process a password. And we can get more into the details as we go down to the verified challenge. But for now, we want to take some time to wait so that when a hacker who's trying to identify users in the system, if they were to make a login request for a user, you don't want that login request to return immediately, really, really fast upon looking up the user, and then return really, really slow if there is a user, right? So if there's no user, it returns real fast, and if there is a user, it returns really slow because now you're verifying a password. So that's more work when the user exists and less work when a user doesn't exist. What you want to do is make it feel to the end user that there's the same amount of work whether the user exists or doesn't exist, because you don't want to indicate to the hacker that the user is there or not. You don't want to give away that information. So we fake it. And we say roughly 250 milliseconds, maybe add some randomness into that timer as well. And then we'll return a status 401 error unauthenticated. Okay, now and that's the end of that branch. The second branch here is this get or create login transaction. Now in this system, and this is a design that I have not actually built myself in the past. In the past, it's usually a one check, and then if you need MFA, I ask for MFA, and so the second MFA checks your first token and approves the MFA. It's kind of a ad hoc measure. In this one, I didn't want it to be ad hoc. I wanted a flow to have a transaction ID, like it starts a transaction when you make the first challenge, or it will retrieve a transaction ID if you are in the middle of a transaction. So that makes one more additional requirement on this first challenge request, that if you have a transaction ID, then you should pass that transaction ID into it. All right, so getting into that, I can talk a little bit more about the transaction info, but basically it'll be a randomly generated transaction ID, and it will tie to the user ID. And then in that transaction, you'll likely keep track of things like you've successfully cleared your password, you've successfully cleared the MFA, you've successfully cleared your security questions, or whatever other extra password challenges you want to throw at your users. It will keep track of the ones that are successful and the ones that are required. Sometimes they exist and they're not required for a given app. So your transaction is going to keep track of that. So we store a transaction into the database with whatever state it's in. We'll continue on to call pre-login webhook, which is what I talked about a little earlier, calling those webhooks. So down here in the webhook swim lane, we call the configured pre-login webhooks, which would just be it's likely just a call to a function that says, here's the webhook I'm calling, and it will retrieve from a database the list of webhooks that are configured, and then that particular one will call based on its designed interface. I haven't designed the interfaces for webhooks. They'll probably be pretty basic. They'll say, here's the webhook I'm calling, and here's the user ID that this particular event has to do with. Things are always subject to change, but that's likely the direction I'll be going. Okay, so let's continue on to the verify challenge. All right, so verify challenge has two layers to it, maybe a little more. So the challenge, you have to figure out what challenge it is. It could be a password challenge. It could be a time-based one-time token. It could be a one-time token, which is just something, maybe you sent it in an email or in a text message, which text messages are arguably not the safest place to put your multi-factor code, but that's something we can talk about in another video. And then any other challenge that you configure or build, or that I configure and build, depends. I'm hopefully going to make this available to other people to modify and upgrade. So more on that later. So the verify challenge, you identify what challenge it is, and then you compare the token that was given to you against the token that is expected. Now those tokens, let's say it's just in the case of a password. A password, when you store it in your database, you want to do special kind of hashing and salting. And actually, that's a good topic for another video as well. I'd love to talk more about that. But in the basic case, I'm set up to use bcrypt, which is when you implement it in Golang, you pass your password in. It generates when you're trying to save the bcrypt version of the password, you pass it through the bcrypt function. It will generate a salt, and then it will hash it based on the amount of hashes that you need it to go through. And what you're doing is you're making your computer or your server do a lot of work to store that password. And then when the password does come back here in this verify challenge, another password comes in, and you need to compare the stored hashed value of that password and the password value that was passed in. And you need to do the same work on that password that was passed in that you did on the original. So when you do all that same work, it should come back as the same text value that's in your hashed storage. So that stored value should match, and you did the work. The reason you do the work is because when a hacker comes and they're trying to guess passwords, you don't want your answer, if this password is valid or not, to come back crazy fast. You need it to be fast enough that the user doesn't care, but slow enough that the hacker trying hundreds of thousands of passwords does care. So that's why bcrypt, give it a lot of work to do, store it. Bcrypt, give it a lot of work to do, and compare it. So that's the basics of a password hashing function, and I'll do another video on that. All right, let's continue on. So if you're successful, right, we compare the tokens, and token, password, security question, anything else, right? We compare it. Was it successful? So let's go down the not successful route. We'll call the update transaction status to failed. We'll set that in the database, and then and all of these can be separate concurrent calls, right? We update the transaction in the database, and then we call the webhook, and then we also send back a failed status to the client, because the client needs to know that they didn't get in. So those three different transactions, right? There's a transaction and the three different calls that we make. We update database, call to the webhooks for a failed login, and return to the client. That can all happen in parallel. Sometimes calling three different things on three different threads is kind of overkill. So you could just call one right after another. It's no big deal because you're already in a separate thread, usually in Go, when you're making when users make calls. That can happen. We have this 401 error unauthenticated. Let's go back to this success check. And if you are successful, what do we need to do next? We go and we check the personal and global security settings for any additional required challenges. And so in this case, if it was password, we verify and the password was successful. And now, Mason's account is also configured for multi-factor code, a time-based multi-factor code. So what we need to do is moving into the next step, additional challenge required. In my case, yes, it would be required. And so the response that comes back from this first call will actually return a 403, which means you're authenticated, but you didn't have enough authorization. And so it will return the error type. So that error type in this case would be MFA required, multi-factor authentication required. In other statuses or other additional challenge required, that error will change. And so I will store in the API documentation what those different error codes will be, so that when you're building a login page, it'll be able to handle that. Also, I'd like to build a login page that handles all of it, so you don't have to do that. You just get to style it how you want. All right, if no other additional challenge is required, then you're in the successful state, and we need to do some things in order to go forward. In here, I'm going to generate a JOT token and generate a session ID, and I'm going to track that session ID. I'll likely keep it in the transaction database. So those transactions can be long-lived or short-lived based on the length of the of the session. And so, and once we've generated that, we can also call that successful login webhook, which is just all of the configured successful login webhooks. Moving forward, we also need to tell the database, update transaction to success. And so we'll call that database transaction. And then once we're done, we'll send it back to the client, say status 200, token ID, access ID, refresh token, all the JOT tokens that we generated. Now, that information will be super useful, and there will be additional changes made in this flow to build out things like an access token. An access token really depends on what system you have and what kind of access you need to provide. And we can get into that in another video as well. Wow, lots of different videos coming from this one. Anyway, I am really excited to build this, and I've started putting together the rest of the system. So I'll go ahead and show a little bit of code here. This is actually, that's my in database memory store, but I have a lifecycle service here that is all about the user's profile. And you see right now, I haven't built out everything like profile webhooks and things like that. So I'm getting to work here. And so what I'm going to need to do is I'm going to need to start writing tests for each one of these boxes. I'm going to write a test, and it will be in a failing state until I've implemented the code to pass that test. And once I've done that, then this whole thing will be complete. And I will use this page as my to-do list, and I will just mark things off as I go to say, hey, this now passes the test that I wrote, and I will turn each one of these boxes green. When all of them are green, we're ready to go. So anyway, it's been a long video. I hope you were interested in what we were doing here, and let me know if you have any questions in the comments. And also don't forget to check out BurgX and try it out. Thanks.